So let's start the deep dive into the world of R square concept, because why I'm telling the world, it means that R square tells the complete story of linear regressions. Okay, so first, before understand the concept of R square, one thing I will be clear. Like R square is not a accuracy; it's a coefficient of determinations. Okay, so what is the coefficient and all these things? Already I have taught you in earlier lectures. Okay, so first understand the what is the R square. Okay, so I start with a mathematical formula: 1 minus sum of residuals divided sum of total. Okay, so SS refer to the sum of square of residuals. You know what is the residual means? Residual means error. Okay, now I write the same equation. I write the same word equation in a mathematical form. So one minus summations I is equal to n. So y minus predicted value divided square divided summation I is equal to 1 n y cap minus by mean model. Okay, so what is this? Okay, so like excess residuals, it tells the models, it tells the models, it tells about the model that we built. Okay, and now SS totals, it tells the about the mean model. Okay, mean models means baseline model. Okay, if you don't know anything about the data, then you simply apply the mean, yeah, average concept. Okay, so in the same manners, when we calculate the R square, first we build the we consider the what is the mean models, and then we build like another models, that is like SS residual with the list squares, list error square, and then we start the comparisons. Okay, so now, if R square simply tells how what your model perform if you compare with the mean model, that is the simply meaning of R square. Okay, if I write here, so R square, it tells the how your model perform compared to mean model, compared to mean model, mean model or baseline model. Simple. Okay, so let's come to the another story. So now I give the like geometric intuition of R square. This is the mathematical story, a mathematical calculation of R square. Now understand the geometrical intuitions of R square. So geometric intuitions in data science, yeah, in machine learning, visualization is the one of the important aspect of any models. If you're not visualized, then you are not able to explain anything in a machine learning or data science. Okay, so always try to believe the like give the some intuition of geometric intuitions, give the some visualization part how it's work, then you understand. Okay, so first I draw the two models, that is called mean model and another is like linear models, yeah, like linear model, yeah, myself model, okay, build model, just for the rough understanding. Okay, so what is the mean models? Okay, so like if I consider the x axis and y axis, okay, and if we predict the experience versus salary, just consider the experience versus salary. Okay, so what is the mean of this model? So just we have to draw a one line that passes through the like average of your data set. Okay, so this is the mean model. Okay, so just for the example, y is the mean. Okay, so I have created one box, I have created another box, I have created one more box. Okay, so like these are the data set xi, and some other point like x2, like one x3, x3. Okay, so like this is a like mean model. So like a square, basically this square part represent the residuals error from your mean. So like if I consider the this error, just for the example, this average y model, average is like 0.5, but this error x3 give the 0.65. So this box represent the y cap minus x3. Okay, this is the concept of mean model. Okay, now come to the next part, that is a linear model. So I have not considered the any mean part. Okay, just I select the data point like x1, like x2, and like x3. Okay, so like how, what is the error from this particular line? There are infinite line possible that passes through the all multiple data point. Okay, so I have to identify which perfect line that cover the almost all data point. Yeah, that will explain the complete complete story of data set. That is called linear models. Okay, so this is called f linear, yeah, linear model. So from geometrical representation, you can easily understand which model is performed. Here is the like average mean model. Here is the linear models that passes any fittest line that passes that explain the all data point. Just for the example, if any data point like here is the x4, so you can imagine what is the box size here. It's like a big building tower. Okay, so there is a huge error here. Okay, so that's why mean model is not performed. So just for the understanding, so like if there is like x4, so then we our another line is a passes through from here. Okay, so one last line from this geometrical interpretation, the better the model, less will be the area of residual square. Okay, so like if any model, like just if you perform the mean model, so if mean model is perform well, then square side will be least. This is the geometrical intention of our r square. Okay, I think it's a got it. You understand the concept of. Now I I give the some concept of some interview questions of what is the r square value, and what is the, so my question is what is the best value of r square. So simply r square best value is the like 1, means 100%. That is highly not possible, but For the mathematical purpose, it's the best value for the r square. So when will be r square value is the 1? Okay, so like r square is like 1 minus sum of residuals divided sum of totals. So like when sum of residuals is equal to 0, so when ss is equal to 0, so r square is equal to 1 minus 0 divided ss total. Okay, so now its value will be r square is 1, means that whatever model you have built, that sum of residual will be 0. That conditions will be fulfill the r square value is the 1, means 100%. So when is the and now another condition is the what is the worst value of r square? That is simply 0. When sum of residuals is equal to sum of total is equal. When both value is equal, then r square is equal to 0. So r square is equal to 1 minus sum of residuals and sum of residuals. So when you cut it, cancel out, then 1 minus 1, that is 0. So r square is equal to 0. And now third part, what is the third possibility of your r square? So r square third possibility is like minus infinity when it is possible. So when sum of residual is the more greater than sum of total, that condition will be fulfilled, the r square is the infinity. Mathematically it is possible. Okay, so simply r square is 1 minus sum of residual is very higher than ss total. That value will fulfill the r square minus infinity. That is the simple concept of r square. So if I plot this value, so what is the minus infinity to 1? Okay, so r square value will be fall between minus infinity to 1. That is the complete story of r square. In further lecture, I will explain the what is the adjusted r square, how to build calculate the r square. Okay, so just for the understanding purpose, I give the complete intuition of what is the sum of residuals and what is the r square and all these things. Okay, my writing is not a good, but my concept I will give the concept in whatever I require. Okay, thank you.